Hey, I've got a question for you. What's an ion? Do you know? If not, I'll help you out. The answer is ions are atoms with a charge. So I'll write that out. Ions are atoms with a charge. What's that mean? Consider the structure of an atom. You have nucleus in the center with protons and neutrons. Remember, protons are positively charged. Neutrons have neutral charge, so that's N with a 0 because neutrons have no charge. And then there's electrons going around the outside. So nucleus in the middle, electrons on the outside. Great. How do you turn an atom into an ion? So when we say atom, that means no charge. Ion, when we say ion, we refer to has a charge. So when I talk about atoms, it's going to be referred to, when I talk about like sodium atom, I'll be referring to neutral, and sodium ion is having a charge. Okay? How does that work? Let's look at sodium as an example. Sodium. If you look it up on the periodic table, it's element number 11. That means 11 protons. So here's the deal. Sodium has 11 protons. We're going to assume if neutral, sodium atom has 11 electrons, with E being my favorite abbreviation for electron. Okay, let's look at another one. Lithium. 3 protons, 3 electrons. We'll start here. So proton, proton, proton in the center, and electron, electron, electron on the outside. This is a lithium neutral atom. An ion of lithium has a number of electrons and protons that aren't the same. Because, consider this, protons are positive. It has 3 protons, so 1, 2, 3. Electrons are negative. So if there's 3 of them, that's 1, 2, 3. Notice they cancel out. They balance. Positive and negative cancel out. These cancel out, these cancel out, so it cancels out to neutral. Lithium atom is neutral because it has equal numbers of positive and negative. In order to turn lithium into an ion, the number of protons and electrons is not the same. Now, if you change the number of protons, it's not lithium anymore. If you add a proton, it's now beryllium number 4. If you subtract a proton, it's now helium number 2. Don't ever alter the number of protons. Instead, you alter the number of electrons. What if you add an electron? If you were to add one more electron, you would be adding more negative charge. So this cancels, this cancels, this cancels. If you add an electron, you would have a net charge of -1. Adding electrons make for a negative charge. Now, what if instead you remove an electron? So first of all, let's get back to the starting point, okay? 3 electrons, 3 protons, neutral. What if I had taken it down to 2 electrons? That means remove an electron and remove an electron. What did I just do? These cancel, but there's nothing to cancel this proton. You have a charge of +1. So, add neutron. Sorry, I don't know why I just said that. If you add an electron, you get negative charge. If you subtract electron, you get positive charge. Now, the charge of an ion depends on how many you add or subtract. If I have 1 uncancelled proton, this has a charge of +1. If I were to take away another one, and leave just one electron behind, this would leave 2 protons uncanceled for a charge of +2. So I would write it as lithium +2. If I had only taken away 1 electron and had 2 electrons left, that would have 2 electrons to cancel 2 of the protons, leaving just 1 electron behind. And instead I would write it as lithium with a plus charge. Lithium +1. That is how it works with ions. You simply add or subtract electrons. That's it. Leave the number of protons alone. So let's look at a couple more examples. Okay, so consider on the periodic table there is potassium. Potassium, as a neutral element, has 19 electrons. So neutral ion. Potassium plus is the charge, 1 plus is the charge of a potassium ion. Let's also look at an example, one that goes negative. Let's say sulfur. Sulfur becomes sulfur with a -2 charge when it turns into an ion. Sulfur is element number 16 on the periodic table, which means it has 16 electrons. Now, how many electrons does the ion have? So number of electrons if neutral and number of electrons if it's an ion. Okay, potassium has a +1 charge. Remember, you have to subtract an electron in order to leave an uncanceled proton behind. So I have to subtract 1 electron to get positive, giving it 18 electrons. So remember, subtract electrons for positive ions, add electrons for negative. That means take the number of electrons in a neutral sulfur and add 2 to make 18 electrons for a sulfur ion. Right? That's the hard thing for a lot of students to memorize. Is, again, if you subtract electrons, remember this diagram I drew. This is a beryllium, for example, but it gives the idea. If you add electrons, you make it negative. If you subtract electrons, you make it positive because there's nothing left to cancel out these positive things. So let's practice. Let's do the examples of magnesium and nitrogen and fluorine and let's see, aluminum. Now, just to let you know, magnesium becomes a 2+, nitrogen becomes a 3-, fluorine becomes a 1-, and aluminum becomes a 3+. Go ahead, pause the video now, predict how many electrons the neutral atom has and how many electrons the ion would have. Pause now and try it out. Having hopefully paused, here's what you should have gotten. Magnesium is number 12 on the periodic table, so 12 electrons. Nitrogen is 7 on the periodic table, so 7 electrons. Fluorine is number 9 on the periodic table, so 9 electrons. And aluminum is number 13, so 13 electrons. All right, magnesium, 2+. Subtract 2 electrons to make 10 total. Nitrogen's a 3-, so we got to add 3 electrons. 7 + 3 is 10 electrons. Fluorine, negative, so add 1 to this, 10 electrons. There is a reason why these all have the same number of electrons. We will get into it when we talk about electron configurations later on in the year. Aluminum, 13 electrons, -3, because you subtract to make positive, 10 electrons. All right, hopefully that helps.